Welcome to the third lesson in organic chemistry. So we're going to be learning about carbohydrates and sugars. So carbohydrate and sugar is the exact same thing. Carbohydrate is another word for sugar, sugar is another word for carbohydrate. But if we actually take the bits at the bottom here, these are some examples here. Glucose is a carbohydrate, starch is a carbohydrate, saccharose is a carbohydrate. You might be going, how do you know? Look at the bottom here. I have written carbohydrate CH2O. So essentially a carbohydrate, this carbo means carbon, hydrate means water. Carbon, water. It's basically anything. So if we were to times that by 2, we would get C2H4O2. And look, they're starting to look like these numbers. And if you keep going up and up and up and up, you'd eventually get to like these sort of numbers. That's all it is. That's all carbohydrates are. It's carbon and water. And that's all your sugar is, carbon and bloody water. So now we know what a carbohydrate or a sugar is. These are like hydrocarbons. They're a different type of, not hydrocarbon, they're a different type of organic molecule. So I'm going to keep going. So this is glucose. This is the base sugar. And it looks very, very, very complicated. All this here is the structure. This image here is the structure of glucose. So glucose molecule, this is what it looks like. This is the drawing of it. Very complicated molecule. Don't worry too much about the structure yet. This is the formula here. C6H12O6. That is the base of all sugars. Glucose. You got to say, remember how we can attach a lot of these organic molecules into chains? Yes, you're right. And it does work with sugars as well. This is essentially what we're making here is saccharose, which is the sugar you usually eat. It's table sugar, like the stuff in your cupboard or pantry. This is usually what it is. It's called saccharose, which is a table sugar. So essentially what we've got here is what we're doing is we're using a method called hydrolysis to do this way. Essentially what we're doing is we're adding 2 of these in a chain, and it's going to remove one of the hot water bonds from it, which is going to give you saccharose. So you're adding these 2 into a chain, and then you're getting rid of one of the water bonds, which usually would go here. I've just drawn that line. You're removing that to connect the 2 together, to connect these 2 into a polymer chain. Or we call this a disaccharide. Saccharide is just another word for polymer of sugar. So monosaccharide is 1, bisaccharide is 2. I think any more than like 8 or 10, somewhere around like lots and lots and lots of them, I call it polysaccharide. Just a biological term for a chemical name. Polymonomer. They're just for sugars only though. So we get rid of our H2O, and then so we do the math here, we get C12. So what's C6H12O plus O612O6 minus H2O? It's going to give you C12H22O11, which is saccharose. Well, we can also do, so we can calculate, so we know C12. But then we've got 24 hydrogens here. How come it's 22 here? Because we're getting rid of 2 hydrogens, as stated up here. So it's going to become H22. 24 minus 2 is 22. Then we're getting O6 plus O6, going to give us O12 minus 1 oxygen. From up here, it's going to give us O11. So there you go. And then this is basically what the 2 would look like together. There's 2 glucoses, but there used to be like one of these guys here, HOH, which makes water. We're getting rid of the one in here to connect the 2 together. It's called hydrolysis. That's the process called to actually make this happen. So now we're going to do some questions over here. So I'm going to leave you guys with 2 questions. One is a reaction, and one is just another question. So, what is the name for glucose called in carbohydrate terms? Carbohydrate monomer terms. Now, what I mean by carbohydrate monomers is, work out the question, see if you can work out the answer, and then I'll tell you what I mean. Okay, I'm assuming you paused. What I mean by carbohydrate monomer So remember I was talking before about saccharides. It's essentially the biological way of saying a monomer of sugar. So, which we know is glucose. So we know it's one monomer, or one of a polymer, so a monomer. We call it, as I said before, a monosaccharide. We call this a monosaccharide, yeah? It's called a monosaccharide. Okay, that one might have been a bit of a hard question. So let's try a reaction one now, which might make a bit more sense and not is made up in my own terms. So let's do one on a reaction. So hydrolysis is adding or taking water from it. That's basically what I was showing you before. We had two glucoses, and essentially I was using hydrolysis to build the new one. So now what I'm going to do is I'm going to do a similar one, but I'm going to use saccharose, or your table salt. What I'm going to do is we're going to add another part. We're going to add a glucose to it. We're going to add glucose to this. So we've got the saccharose, adding the glucose. We're taking away H2O. What are we going to end up with? Now, so what do you think this one's going to be? We are going to basically end up, what's C12 plus C6? C18. Alright, so we've got C18. Okay. Then we're going to have H22 plus 12 is 34. 36, 34, yeah. Plus 34 minus 2. 32. H32. And we're going to have O11 plus 6, which is 17 minus 1. That's going to be our next molecule, C18, H32, O16. Now, I don't know what this molecule is called. I'm sure a quick Google search would give you the answer. So that's basically all you got to do. Thank you for watching.